Hello everyone. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College. Today we are going to learn about performance concept in computer architecture. So, what is called a performance means what? Suppose if you have a two system or two computers, then how to say this computer is better than that another one means what? Based on that execution speed. So here, the important parameter, the important attribute of the performance of the system is nothing but what? Execution speed. If the execution speed is less, then execution time is less than other computer, then easily you can say what your computer is produced better performance than other one. So when trying to choose among different computer, performance is an important attribute. The CPU is said to be faster or has better performance running this program if the total execution time is less. So today we are going to learn about that some important attribute about performance. The first one, throughput and response time. The second one, measuring performance. The third one, CPU performance and its factors. The fourth one, instruction performance. Then the fifth one, classic CPU performance. In this video, we are going to learn about throughput and response time. So what is called throughput? So throughput, it is also called what? Bandwidth. So what is called bandwidth means what? Suppose if you have an internet connection in your system, whatever that internet speed means what? Like 1 Gbps. So 1 gigabits per second. That is called what? Your internet bandwidth. So what is the meaning means what? Per second, you are able to upload or you are able to download 1 gigabits data. That is called what? A bandwidth. So the simple definition of throughput is the total amount of work done in a specified time. That is called what? A throughput. Decreasing response time almost always improves throughput. Suppose if the one system which takes more number of execution time, the another system, the same program can be run in another machine. That machine will takes only less number of execution time. In fact, the second one will produce a better performance. So the throughput is depends on the execution time. So I want to increase the performance of the system, then obviously I have to reduce or I have to minimize the response time or execution time for any task. What is called response time? Here, the response time is also called what? Execution time. The total time required for the computer to complete a task, that is starting time to ending time. So whatever the time means what? That time which includes disk access, because I need to fetch the data. Where the data is available? The data is available in secondary storage device. So we have to fetch the data from hard disk. Then after fetching the data from hard disk, that will be temporarily reside in that main memory. Again, we have to access the data from main memory. So the memory access time also included. Then IO activities. I can get the data from any one of the input device. I can store the data into any one of the output devices. So that is also, that time also included. Then operating system overhead. Then CPU execution time and so on. So all the times will be included. That is called what? Response time. So the response time is also called what? Execution time, and the starting and ending of the particular task. Starting time and ending time of the particular task is called what? Response time. If you reduce the response time, automatically the throughput will be increased. So relating performance and execution time for a computer X. So performance of X is nothing but what? 1 divided by execution time of X. So performance, to increase the performance, we try to reduce the execution time. So the performance of X is nothing but what? 1 divided by execution time of X. This means that for two computers X and Y, if the performance of X is greater than the performance of Y, then we have the equation performance of X greater than performance of Y. With respect to execution time, the same equation will be rewritten by, instead of performance of X, you can write 1 divided by execution time of X. Instead of performance of Y, you can write with respect to execution time 1 divided by execution time of Y. So that is a reciprocal. Obviously, execution time of Y is greater than execution time of X. It means the execution time of computer Y is longer than the execution time of computer X. Execution time. In terms of speed, you can tell that computer X is faster than computer Y. With respect to execution time, computer Y takes more time than computer X. So the relative performance X is n time faster than Y. We will use the phrase X is n time faster than Y, or equivalently X is n time as fast as Y, which means performance of X divided by performance of Y equal to n. If X is n time faster than Y, then the execution time of Y is n times as long as it is on X. So instead of performance, you can rewrite the equation, same equation with respect to execution time. Therefore, performance of X divided by performance of Y equal to execution time of Y divided by execution time of X, which is equal to n. For example, if computer A runs a program in 10 seconds and computer B runs the same program in 15 seconds, how much faster is A than B? We know the equation already, right? That A is n times as faster than B. So the performance of machine A divided by performance of machine B equal to execution time of machine B divided by execution time of machine A equal to n. So in this example, execution time is our input. So therefore, the performance ratio is execution time of B is 15 seconds divided by execution time of A is 10 seconds, which is nothing but what, 1.5. Therefore, computer A is 1.5 times as fast as B. The final conclusion, computer A is 1.5 times speeder or faster than computer B. With respect to execution time, computer B is 1.5 times slower than computer A. I hope you understand this throughput and response time. Thank you.